Welcome to Lesson 3.3. Today we're going to talk exponents. Learning objectives for today. We'll learn to identify whole number powers, bases, and exponents. We'll be able to evaluate powers with a variable base, and we'll be able to write variable expressions involving exponents to represent and solve real-world problems. Here's our real-world example to start the section. Make sure you pause the video and get this read before moving on. Identify whole number powers, bases, and exponents. So sometimes we have to multiply the same number several times. We can say that we are multiplying the number by itself in this case. So 4 times 4 times 4 is 4 multiplied by itself 3 times. So when we have something like this, it's helpful to use a little number to show how many times to multiply that base number by itself. That little number is called an exponent. So instead of 4 times 4 times 4, we could write that as 4 raised to the third power, because there's going to be 3 4s that we're multiplying together. Okay, so we're going to start writing things in exponents, so we're going to go from expanded form, which is the 4 times 4 times 4, to the exponent form, which would be 4 to the third. Now, in the exponent, the base number is what we would call the number being multiplied by itself. Okay, in this case, the base is 4. Exponent tells us how many times to multiply that base number by itself. So in this case, our exponent is 3. So using an exponent can also be called raising to a power. The exponent represents the power. So here, we would read that as 4 to the third power. So we're going to write the following in exponential notation. So we're going to write it as an exponent. You'll notice we've got 6 times 6 times 6 times 6. So we're multiplying 6's together, so 6 is our base. What our exponent is going to be, we count the number of 6's. I got 1, 2, 3, 4 6's, so it'll be 6 to the fourth power. So now we're going to go the other way, write an expanded form. So 5 is our base, so 5 is what I'm going to be multiplying together. My exponent is 3, so that tells me that I should have 3 5's being multiplied together. So it would be 5 times 5 times 5. So now we're actually going to evaluate. So for this problem, 4 to the third power, we're going to take a 4 and we're going to multiply it by itself 3 times. So 1, 2, 3, and we're going to multiply. So we can multiply these one at a time. 4 times 4 is 16. So I've got 16 times 4. 16 times 4 is 64. 4 to the third power is 64. Now we're going to evaluate 2 cubed plus 4 squared. So for each one, for the first, my base is 2. My exponent is 3, so I'm going to take 3 2's and multiply them together. Whoops, that's supposed to be a 2. Now I'm going to add to that. I've got 4's, and I've got 2 of them being multiplied together, so 4 times 4. So I can multiply these. 2 times 2 is 4. 4 times 2 is 8. 4 times 4 is 16. So I've got 8 plus 16, which is 24. So 2 cubed plus 4 squared is 24. Go ahead and pause the video and answer these 3 questions before hitting play and seeing how you did. So for the first one, we got 5 3's being multiplied together, so we would write that as 3 to the fifth power. For the second one, I've got 6 to the third power, which means I should have 3 6's being multiplied together, so 6 times 6 times 6. For the last one, 4 to the third minus 5 squared, I've got 3 4's multiplied together minus 2 5's being multiplied together. If I multiply the 3 4's together, I get 64. I multiply the 5's together, I get 25. 64 minus 25 should get me 39. So now we're going to switch to evaluate powers with variable bases. So we were dealing with numbers to begin with, and sometimes it's easier to just simplify. So it makes more sense to do 16 than it does to work with 4 squared. So exponential notation really comes in handy when we're working with variables. It's easier to write y to the 12th than it is to write 12 y's being multiplied together like you see there. We can simplify by using exponential form, and we can also write out the variable expression by using expanded form, repeated multiplication. So this will work the same way it did with numbers. So if I have x to the fifth power, that means I'm going to have 5 x's being multiplied together. So x times x times x times x times x. I can also do the same going the other way for exponents. My base is going to be a, and I've got 1, 2, 3, 4 of them being multiplied together, so I would write that as a to the fourth. Now I'm going to multiply m cubed and m squared. So for this one, m cubed, that's m times m times m. And I'm going to multiply that by m squared, which is m times m. Well, if you'll notice, for all of them, my base is m. And how many of them do I have? I got 1, 2, 3, 4, 5 of them. So my answer would be m to the fifth. So our rule, when we multiply variable bases with exponents, if the bases are the same, we can simply add the exponents together. You saw that with the last one, m to the third times m squared. I got m to the fifth because 3 plus 2 is 5. I can do the same thing here. X to the sixth times x cubed. My base is the same, so I keep it that way. So I can add my exponents together. So I'm going to do 6 plus 3, giving me x is raised to the 9th power. Now we're going to raise it to an exponent. So this problem is x squared raised to the third power. So what that would look like is I have 3 of them being multiplied together. So I've got x squared times x squared times x squared. So for each one, x squared is x times x. X squared is x times x. X squared is x times x. And I'm multiplying all of these together. So my base is still x, and I've got 1, 2, 3, 4, 5, 6 of them. So it's x to the 6th power. So x squared raised to the third power is x to the 6th. So our second rule is when we raise a variable expression with an exponent to another power, we simply multiply the two exponents together. So a simpler way I could have done the last problem, x squared cubed, I could have done x raised to the 2 times 3 power. 2 times 3 gives me 6. I would have gotten the same answer as I did before. Rule number 3, anything raised to the 0 power equals 1. So if I had x to the 0 power, I would get 1. If I had y to the 0 power, I would have 1. Even if I had a number, 9 to the 0 power, I would still get 1. So anything raised to the 0 power gives me 1. Go ahead and pause the video and answer these 3 questions before hitting play and seeing how you did. For the first one, there are 7 a's being multiplied together, so we would write that as a raised to the 7th power. For the second problem, I'm multiplying a cubed and a to the 8th together. So since my base is both a in both of them, I keep it a and I add the exponents together, 3 plus 8, giving me an exponent of 11. So I have a to the 11th power. For the last one, I've got x to the 4th squared. Since I'm raising an exponent to a different power, I multiply those two exponents together. So I do 4 times 2, giving me 8. My answer would be x to the 8th power. This can also be used to solve real-world problems, and we'll go ahead and see how that works on the next slide. So Karen swam 4 miles during the first week of camp. So in week 1, she swam 4 miles. Every week thereafter, she increased the number of miles she swam by 4 times. So to get the second week, we take that one and we multiply it by 4 because it's increased by 4 times. So she swam 16 miles that second week. Third week, increase it by 4 times, so I multiply it by 4 again. I would get 64. And then finally the fourth week, I would take that 64 and then multiply it by 4 again, and I would get 256 miles that she swam in week 4. Go ahead and read how the real-life example is completed before moving on to the next slide. Just some things to remember. Remember that the base is the factor that you multiply a number of times by itself that is designated by the exponent. It is important to still use order of operations when evaluating expressions that have a number of operations. And remember that an exponent is a little number that tells you how many times to multiply the base by itself. Remember that the base is the big number in the variable expression that we're multiplying by itself however many times. Exponential notation is when you write multiplication using a base and an exponent. Expanded form is when you remove the exponent from the base and write it out using repeated multiplication. And a power is any expression in the form of a to the n. The power is also used to refer to the exponent.